find the all pair shortest path problem, right? So suppose that a weighted graph is given. So we are given a weighted graph, so that may be directed or undirected, right? So either it can be a directed graph or it can be an undirected graph is given for us. Now we are supposed to find the distance, that is the length of the shortest path from each vertex to every other vertices of our graph. So what you are doing, you are finding the shortest length or path from each vertex to all other remaining vertices of the graph. So we call it as all pair shortest path problem. Now in our previous session, so we have discussed about the Dijestrar's algorithm. So what does it says now? That is used to find single source shortest path problem. Now there we are taking one source, but here from each vertex to all the remaining vertices, now you are supposed to find the shortest path. And the distance from various vertices to the other vertices are represented using a n cross n matrix, which is called as the distance matrix. Now here we are going to call it as a distance matrix D. So when the weight matrix is given for us, that is initially when you are having weight matrix, this especially, now how we are going to represent a weight matrix? Now in our weight matrix, now we will be having three values. So one is 0, right? So we can say W of ij will be equal to 0 if I is equal to j. That means if which vertex you are considering, now that from that vertex to the same vertex, now you don't have any distance, so obviously we write distance as 0, and we will be having infinity. Infinity means if there is no edge between vertex I and j, so we represent it as infinity. And x is nothing but the cost what is given on that particular edge. So x is what? A positive value if the distance between I and j is given. Clear? Now let us see, a graph is given for us, right? This is a weighted directed graph. How do we represent the weight matrix for this graph? So now we know that it has got A, B, C, D, 4 vertices. Now I will write A, B, C, D, A, B, C, D. So now first row, first column, this one, 8th row, 8th column. So now from A to A, you don't have any path itself, because already you are inside A only. So obviously it will be 0, right? So here we have said that W of ij will be equal to 0 if I is equal to j. So I and j are same, so it will be 0. Again here B same, it will be 0. C same, value is 0, and D 0. That means the diagonally always the values will be 0. Next, infinity. Infinity means there is no edge. Now we will go to this first row, second column, that is AB. When you are looking 8th row and Bth column, from A to B, do we have an edge? Yes, we have a directed edge, and what is its cost? 5. So we are going to write 5. Clear? So next, A to C. So A to C, you don't have an edge directly, right? So we are going to represent it as infinity. You don't have an edge, so there is no edge between A and C. Now similarly, A and D, edge is there, but direction is in reverse order. So we say that from A to D you cannot go. So infinity. So in the same fashion, the entire weight matrix is written for us. Now this is how we write the weight matrix. Now our task is to find the distance matrix, right? So our task is to find the distance matrix D by applying the Floyd's algorithm. That is, what it says, if you consider vertex A, from A to B, what is the shortest path? Is this only the path, or is there any other path which is giving you the shortest? Now if you take from A to C, so what is the shortest path? Similarly, A to D. Next, from B to A, B to B, B to C, and B to D. So like this, from every pair, all pair, that is why it is called as all pair shortest path, from each vertex to all the remaining vertex. Clear? So if you take vertex A, from A to all the other remaining vertex, what is the shortest path? If you consider B, from B to all the other vertices, what is the shortest path? From C to others, what is the shortest path? Like this problem, now we are going to use the Floyd's algorithm in order to solve this particular problem. So now let us see now how the Floyd's algorithm, or how we are going to find. Now here, now if the graph does not has any cycle of negative length, right? If the graph is not having any cycle, then the distance matrix can be generated by the Floyd's algorithm. That means now compulsory the graph should not have a cycle, right, of negative length. Length should not be negative, because when you are finding the distance should be positive only. So now here, now in just like Warshall's algorithm, here also we are going to create series of matrices. So it starts from D of 0. So now D of 0 is the distance matrix when you are considering the first vertex. So D of 1 is the distance matrix when you are considering the second vertex, like this till nth vertex. So how many vertices are there in our graph? So many matrices are being created, generated, and the last matrix will give you the complete distance matrix, right? Now how we are going to do this? Now we are using a very simple formula. Now when you want to create an ith matrix, right? So D of ij, initially D of ij of 0. 0 means the first matrix. Now initial matrix is the given weight matrix itself. And when you want to construct the next matrix D of ij, now since you want to find the minimum, so now what will we do? So D of ij of k is equal to minimum of D of ij of k minus 1. That is in the previous matrix, what was the value between that ith vertex to jth vertex, right? Suppose say that now you have got let us say you have got a vertex I, right? Now you have got another vertex j. Clear? Now there is a path from I to j. Let us say that you have got a path from I to j. So now when you want to find this, now you are going to see minimum of, now if there is a path, what is the cost for this path? Say for example the cost for this was 5, comma D of ij plus D of kj. Now suppose say that you have got another vertex k, you have got another vertex k, right? Now if there is a path from I to k, if there is a path from I to k and k to j, that means if you want to go from ith vertex to jth vertex, directly you can go here. If you go directly, cost is 5. This is what it says, the previous value. Suppose if you have got an vertex k, so at that time you have to find what is the distance from I to k. From I to k, what is the distance? Suppose say that if the distance is given is 2 here and the distance given is 1. Now what we are going to do is that now we add this I to k plus k to j. So 2 plus 1 is 3, and you know that 3 is less than 5. So now we are going to consider minimum between these two values, minimum of 5 and 3, which is that this one. So instead of going from I to j like this, if you go from I to j directly, cost is 5, but if you go via k, the cost is 3, which is less than 5. So obviously we are going to select this path into our resultant value. So this is how we are going to use the formula, and we are going to construct the distance matrix. Now let us try to solve an example in this, so that things will be more clear for us. So now what is our problem? Now find the all pair shortest path, right? So now you are going to find the all pair shortest path problem. So let us before going to the example, now we will just look into the algorithm first, right? The same, so we have used two important formulas, right? So now the same formulas we are going to write. So now what does the algorithm, Floyd's algorithm says? Initially we are given with a weight matrix, right? So weight matrix is the input, and what is our output? Distance matrix D. Now you are going to process a matrix, so you need 3 for loop, just like Warshall's algorithm, same Warshall's algorithm. Initially your distance matrix is assigned with the given weight matrix. You have for loop, 3 for loops k, I and j, which goes from 1 to n, and what you are doing, d of ij is equal to, you are going to calculate minimum of d of ij comma d of ik plus d of kj. right? Whichever is minimum, you are going to put in this new value, and finally you return D. So this is how the Floyd's algorithm is being written. Now when you try to do the analysis, now analysis is same like Warshaw's algorithm, because we have 3 for loops, K loop, I loop and J loop, and we have only one addition operation, and if you remove one by one summation, just like in our first unit how we have solved, we can solve this. So finally we will get n cube if you remove all these summations. So the time complexity of Floyd's algorithm is also same as Warshaw's algorithm, that is n cube. So this is about the analysis, because it is very simple and we are using the matrix representation in our particular problem. So now let us try to take the simple example and we will see how we are going to construct. So now the problem says find the all pair shortest path problem for this given graph, right? Now a graph is given for us. Now the graph consists of 4 vertices, that means you have to construct 4 distance matrix. Now first we consider the cost matrix or the weight matrix of the given graph. Now this is a graph, now we write the cost matrix. So now the initial matrix itself will be D of 0, right? So that will be our distance matrix, right? So 1 minute, once again I will load the file. Okay, so this is our given graph. So what we told, the initial matrix, that is the weight matrix, is our D of 0. So how we got this? So from the given graph. So now we will say A, B, C, D, 4 vertices are there, right? So from A to A it is 0, right? B to B also will be 0, diagonally all values will be 0. So then from A to B, you don't have a directed edge, so we represent it as infinity. We will consider infinity for this. Now similarly from A to C, its cost is 3, so A to C 3, and from A to D you don't have an edge, so we will write as infinity. So like this we have constructed the entire cost matrix. Now it is very simple and easy, you can write the cost matrix. So now first step, now what we are doing, now we consider the shortest distance through vertex A. One by one, we start with vertex A, then B, then C and D. So we have to find all the shortest path from vertex A to all the other vertices of our graph, right? So now we start with finding the shortest distance through vertex A. Now since you are going to start with A, now you consider the Ath row and Ath column. So what we do, we circle like this, we circle the Ath row, right, and Ath column, that is first row and first column we are going to circle, and we start to construct D of 1. So this is D of 0, initial matrix. Now we will go for the next distance matrix, D of 1. So now to get this value, now listen carefully. Now what you have to do first is, the whichever row and column you have circled, right, you have circled the 8th row, what are the values are there? 0, infinity, 3 and infinity. Write it as it is here in this matrix. So you write 0, infinity, 3 and infinity. Then column, so this column you have circled, right? So 0 to infinity 6, write as it is, 0 to infinity 6. Clear? So first write this and this column, circled one, rows and column. Then diagonal, so diagonal all values are 0, you write all these values of diagonal as 0. Clear? So now second is over. Then you take this first row, that is circled row. In circled row, wherever infinity is there, see here infinity is there, right? Here infinity is, that means this entire column values you write as it is, right? So that is, now let me take in the first case, let me show you how we are going to write, so that the things will be more clear for us, so that from next step you can clearly observe how we try to do it. So we'll take the vertices A, B, C, D. So A, then we have here B, vertex C and D, right? So now what we told, this row, first row you have circled because you are starting, step 1 you are starting with the 8th vertex. So this you have circled. So what values you are having here? So you have values, you write that values 0, infinity, 3 and infinity, right? So then this column you have circled. So what values? 2, 0, 2, infinity, 6, 0, write down the value same, don't change it. So 0, 2, infinity, and last value is 6. Now all the column diagonal are 0, so all the diagonal element you write it as 0. So that means B will be 0, right? C will be 0, and D will be 0. Okay, so now still some values are left, we have to fill. Now what you have to do is take the circled row. So this first row you have circled. Now in this row, where all infinity is there? Now you see here infinity is there, that is under bth column, right? Here infinity. What values are there here? You write completely as it is here. We have 0, infinity, 7, infinity, 0, infinity 0, next value is 7, next is infinity. Here 3 is there, don't change any values. Again here infinity is there. So in this entire column, what values? Same values you write it in the next matrix, that is D of 1. So this is where D of 1 we are constructing, right? So what is this value? So you have infinity 1. Clear? Now this is over. Now you take this column which you have circled. Now check any infinities are there in this column. 0 to infinity, yes. Now this value, whatever values are there here, you write as it is here. Infinity 701, already all values came, right? So now we have filled all the values, but there are two values which are left. What is that? Here, that is B and C. Still we have to get this value, and D and C. Clear? Now this is what we have got, this matrix. So from this step you have got. Now still now only thing left is, now this value you have to get, and this value you are supposed to get. So now we will find the value for B and C. So this value we have to get, right? B and C. Now this B and C is equal to minimum of, we are going to use that formula. B and C is equal to minimum of BC, right? Previous value of BC. So that means in this matrix, what is the value of BC you are having? Infinity, right? BC was infinity previously. Now infinity, comma, BA plus AC, right? Now how you are going to get this equation? Now you see, now you have to find this value, right? You have to find this value, that is BC, this value. Previously it was infinity, now I want to find a new value. Now to do that, now first you go to this B. You are starting from, from which vertex you are starting? So from here, right? Because you want to find BC, B and C. Now you take a value which is in our circled rows and columns only. You have to just look into the values which are in the circled rows and column. Now here 2 is there, that means from B to A value is 2, right? B to A value is 2. Now here if you come here under C, value is 3, that means from B to C value is 3, correct? So what we are going to write? Comma BA, B to A. So this value 2 you take, plus next is this one, right? So what is this one? It is AC, right? This value is B A, and this value is AC plus AC. So now you can see here, if you remove this A, so this will be BC. This is what we want. And what is the value of AC? It is 3. So 2 plus 3 is equal to, this becomes 5. Now which is value is minimum? Minimum between infinity and 5 is the minimum. Now therefore, now BC value what we got previously, BC was infinity, now we got a new value 5. You write this new value 5 here. Clear? Now we are going to go, we got this value 5. Now you should get this one. What is that? DC. You have to find DC value. Now what is DC? DC is equal to minimum of DC, previous value of DC. What is this value? Infinity. So DC value is infinity. Right? Now you have to find this new value here. Now this is equal to how you write? So this value you are going to take. That is, what is this value 6? It is DA. Dth row, that is vertex D and here A, right? DA. So DA plus this one you have to find. You look into the value which is there in the circled one, 3. So this corresponds to which one? AC plus AC. Right? AC is 3. 6 plus 3 is 9. So infinity and 9, which is minimum? 9 is the minimum value. So we write here 9. So now we got value for D and C, so which is 9. Is this clear now? So now this is what we have done, step 1. So where we have constructed D of 1. So next, in the next step, what you are going to do? Now you are going to construct D of 2. So step 2. Now you now consider the shortest distance through vertex B. Now you have to find the shortest distance from vertex B. Now to do that, you are going to consider the bth row and bth column. So now you go to your D1 matrix, circle your bth row and bth column. Clear? Now after circling, what we have to do? So we told 3 steps. What is the first step? Whichever row and column you have circled, you write in the next matrix as it is. So that means you have circled this one, this column, that is infinity 0, 7, infinity. Write the values as it is, infinity 0, 7, infinity. So then which row you have circled? Second row, 2, 0, 5, infinity. So now write down as it is, 2, 0, 5, infinity. Now third step, all diagonals 0. So write down in the matrix all diagonals 0. Right? Now here I have missed. Now here also you can write 0. All the diagonals values are 0. Next, now in your circled rows and column, you check any infinities are there. Now you can see here infinity is there. Right? Here infinity is there. So this entire row value will be as it is, 0, infinity, 3, infinity. Now here again infinity is there. This entire thing write as it is. So 6, infinity, 9, 0. Right? This is over. Now look into this row here. So 2, 0, 5, infinity. Here infinity is there. This entire row value write as it is. See, infinity, infinity, 1, 0. Now after filling all these things, one value is missing here for us. Right? What is this value? CA. CA value is missing. Now here I have solved for CC, but we know that CC always it will be 0. If you calculate also you will get 0. No need to calculate because it is a diagonal. Right? Now only one value we have to calculate, that is CA. Now we will find that value. So use the formula. So CA is equal to minimum of CA, comma, right? In your previous graph. So what is the minimum value of CA? Infinity. So this is our CA. Clear? So now you have to find which value? This value, right? So previous value was infinity. So now to find this value, it is minimum of CA, comma, this is value. So inside our circled one value column, right? In this column, so it is 7 for this. So this is corresponds to what? CB. So it will be minimum of CB, right? And this one. Because we are considering from this, right? B and B. Now you want to find this value. So if you want to find this value, you have to look into this value and this value. You have to look into this 2 and 7 to get this one here. So now what is these two values? So CB plus BA. CB, that is 7, plus BA, this value is BA, right? 7 plus 2, 9. So infinity and 9, which is minimum? 9 is minimum. So this value will be 9 now. Clear? So now all values are filled. So now we have constructed the matrix D2. So step 3. So next we go to our third step. So in third step what we do? Now we start from third row and third column, because we are going to start with vertex C and C vertex, right? So third row and third column, now you are supposed to circle. So now you want to construct D3. So to construct D3, what you have to do? Now you are going to circle the third row in your previous matrix. Clear? And third column. Like this, you circle it. Okay, once you have circled, now we will fill this D3. Now write whichever row you have circled values as it is. What is the values you have got? 9701. So write down 9701 as it is. Now circled column. So what values you have? 3509. 3509. Write as it is. Clear? Now diagonals. All diagonals value write it as 0. See 0, 0, 0, 0. Now third step. Now check any infinities are there. Right? Now you look into this particular circled row. Now here 9701. No infinity. Suppose if any infinities are there, like say assume that if this value was infinity, so then entire row values, whatever is there, sorry, entire column values, if this was infinity, means here what values are there, you have to write as it is here. But we don't have infinity, right? Now look into this column. Now 3509, no infinities. Suppose say that if this was infinity, right, now this entire value of this entire row will be written as it is, like in our previous case. But here no infinities are there, so we don't do any changes. So now we got D of 3. Now you see that how many values now we have to get? 1, 2, 3, 4, 5 and 6. Now 6 values you have to calculate, right? So now we will calculate from A of this one, AB. So no need for AA, because AA will be 0 only. If you calculate also you will get 0, so no need to waste time in calculating this one. This step you can leave. Now we will directly start with AB. So AB, right? Now to find this, now go to this previous matrix. You need this one. You want to find this value AB. So now to get AB, now which are the two things you are going to see? One is this value and the other one is this value. Corresponding to this particular row, circled value is 3 here. Now here it is 7. Now what is these two values? So we will write AB equal to minimum of AB comma. Now we will take this one, AC. Right? This 3 is what? AC. It is minimum of AB comma AC plus, this is plus here, plus, now this one you have taken, right? This one you have taken. Now 7. So this 7 corresponds to what? CB plus CB. AC plus CB. Right? This is nothing but we say that to go from vertex A to B, you are going via C. So from vertex A to B, you can have, there is a directed edge. We don't have any edge, so value is infinity. Now you have an edge, you can go via vertex C. If you look into your graph, you will come to know. Observe the graph, you will come to know. You can go via C. If you go from A to C and C to B, what is the distance you have to add? So cost from A to C will be 3. right? This is 3, and C to B is 7, so 3 plus 7 10. So infinity and 10, which is minimum? 10 is minimum. So from A to B, now we got the value 10. You fill this value here. Next we should find A to D. Now this value you have to find. Now how do you find this value? To get this value, so now you are going to, so A to D, right? Now you are going to look into this one, which is A to C plus this one. So this and this. See, corresponding to this is 3 here in this row, and in this column 1, right? So that is minimum of AD comma AC plus this one CD, right? So what is that? It is, the equation will be what? So A comma D is equal to what? Minimum of AD comma AC plus this value AC, that is 3, plus CD 1. Now you can see what is AD? AD equal to minimum of AD comma AC plus CD, so which is equal to minimum of infinity comma 3 plus 1 4. So infinity and 4, which is the minimum? 4 is the minimum, right? So now we got the value AD as 4. Now similarly BA you have to find. Next is, now BA equal to minimum of BA comma, now it will be, if you look for BA, this one you have to get, right? To get this one, now you see previous value, how much you are having? You are having previous value was 2, right? Minimum of BA, which was 2 comma, now corresponding to this, what is this? 5, and here 9. So 5 plus 9, 5 plus 9, right? You can see here the same equation we are going to write here. 5 plus 9. What is this 5? This is from BC plus CA. So 2 and 5 plus 9, which is minimum for us? So one is 2 and the other one is 5 plus 9, 14. So 2 is the minimum. So we will write as it is. So we don't change. So here we will get the value 2 itself. So next this value here. Previous value is infinity. So this will be, that is BD will be minimum of infinity comma 5 plus 1, right? That is BC plus CD. So 5 plus 1 and infinity, which one is minimum? This is minimum. So what is that value? 5 plus 1 is 6. So here we will get 6. Now down you can check the equations what we have written here. So here B, D, you will get 6, right? So next DA, this value, previous value is 6. Now which we are going to find? This one, right? You should get DA, right? So to get DA, so you are going to start with D, that is this value DC plus CA. 9 plus 9, 18. 18, 6, which is minimum? 6 is the minimum, so we will take the value 6 itself. Next we have to find this minimum between what? Infinity and these two. 7 plus 9, right? 7 plus 9, so 16. Infinity and 16, which is minimum? 16 is the minimum, so we will get this value as 16, right? So in the examination these steps you have to write. Directly if you write the matrix, you will get less values. Now you can see here we got 16, 6 and 16. Now this is our D3, that is step 3 is completed. So now we go for step 4. So in step 4 what we are going to do? So you are going to circle. Step 4 means from vertex D you are going to circle 4th row, right, and 4th column. you are going to circle 4th row and 4th column. So now whatever here we are doing, so you are supposed to write it and practice, right? Take your notes and you have to write all those things, then only you can solve in the examination. So otherwise just by watching the video, now you cannot learn, so you have to solve it manually. So now what we have done, so we have circled 4th row and 4th column. So now you follow the same step what we have discussed. So what you do first, this entire circled row and column value you write as it is in your next matrix D4 in this matrix. So we will write what values are there in the circled row and circled column. Next, fill all the diagonal values as zeros and check any infinities are there in the circled row and circled column here. So but you can see here, now we don't have any infinities, right? So you leave it as it is, no changes. Now you are supposed to fill all these values. You have to fill all these values you are supposed to calculate. That is, you have to start from AB, this one. You have to calculate what is the value of A and B. So now go to your previous matrix. Now A, B, this value you have to find. Now this value is what? Minimum of 10, 4 plus 16. So 16 plus 4 is 20. So 10 and 20, which is minimum? 10 itself. So now here we are going to get value 10. See here, 10 you got. You look into this calculations later, right? You try to solve it manually, so you will come to know. So here we are going to get 10. So next is AC you want to find. So AC, this value. So previous value what it was? 3. Now 4 plus 9. So 9 plus 4 is 13 and 3, which is minimum? 3 is minimum. So we will take down 3 as it is. So here you are going to get 3. So we got 3 here. Next you should find BA. Right? So like this you calculate for BA, BC, CA and CB. So when you do all these calculations and get the minimum value, you write down in our matrix. Now this will be your resultant distance matrix. Now this is your final resultant matrix.